What's up, everyone? This is a snowflake, and there's some CFD on it and some streamlines. So let's look at the orbit. And one thing that's really cool is something I haven't really seen in too many other simulations. When you have the flow coming in, it's like of a certain area, it covers a certain area. Then past the snowflake, the area has dramatically increased. Not to mention the wake, so you have a lot of these streamlines going pretty crazy. So that expansion is really uncommon, and that would explain a lot of the reason why the flow has reduced in velocity so much, simply just because it's going into a bigger area so that the flow rate is the same, so the velocity has to reduce. And considering how porous the snowflake is, it has quite a big weight. And this is like a cross section going through the snowflake from upstream to downstream, and the velocity is plotted. As you go through the flake, the velocity dramatically drops in velocity, so that's pretty cool. And as you go further away, the wake really disperses and becomes a pretty cool pattern. This is the same plane, but it now has the UY velocity, so left to right. And it just makes cool patterns, so let's play and see. And this is the vorticity and the magnitude, so this is pretty cool. As you go over the snowflake, you get a quite high vorticity, and then as soon as you go past, that's really cool. You have this outline of vorticity, which makes sense because the vorticity starts at the surface, so it hasn't really propagated into the rest of the field yet. And it slowly expands and this is the surface pressure in an orbit, so this is upstream, and as you'd expect, the flow hitting the front of the snowflake stagnates a little bit, and then get the high pressure. And it's somewhat what we'd expect. We have high pressure on the front face, low pressure on the wrist face. But one thing that's interesting is where the edges are, the front edges, there is this local minima. There are these local minima, and that's probably because the flow is separating over those regions, and then it sort of attaches a little bit afterwards. That's something you don't see too often. All right, so that's it. Make sure to like and subscribe. Check out the International Aerodynamics Conference. It's a conference we put on every year. Check out the Atmosphere Hawk. It's an instrument that we make to make your experiments better. And check out our courses to make you a better aerodynamicist. Peace out.